geometrical modeling techniques. Why you need for CAD? In this CAD, you have an ICG, interactive computer graphics. Interactive computer graphics is ICG. It's create, transform, display the data in the form of picture or simple. It's used to create the geometrical model with the help of the design problem. It's reflect for an what we still it's human can design the design process. It help of the calculation of speed, visual display, then storage. All those things are calculated by CAD. Fundamental reasons for implementing CAD. There's four reasons. Uh, that four reasons. First one is for an ability of the designer. CAD helps the design for aesthetic analysis, then documentation, all those things. And then this is quality of the design. You know about design can free, error free means it is effective one, and then quality it's not compromising the level. Exact dimension, exact things are getting. This is why how you improve the communication. If you draw in a sheet within a CAD, engineering dimension, standardized, better documentation of design. If you shut out the error, it go for a next level. This communication, the database of manufacturing. In this manufacturing is bill of material and then geometrical model. It's used to for a computer integrated manufacturing application like CNC program of robotics and process planning. Another on the title is design process. The design act, you know about what's a need, what's a problem, what is the synthesis, analysis, evolution, and then presentation. If you start for a design, you have an idea. That idea to start for this usable design, analyze, result, evolution, and then finally you get an optimization to end those things. In the design process, there is a four type of design process available: Shukla method, Paul and Pitch method, Oshak method, Ehrlich method. Shukla method, what the design we need, define the problem, synthesis, and then the synthesis analyze and optimize those things. If that optimize that, you go for an evaluation method. In that process, if anything is not carried out, it go for a continuous improvement for improve the design. After the design can improve and change it, again it's flow for it. If it is no, it is impossible for given. Here finally it's go for a presentation. It's one of the model. In this model, what is the need, what is the problem, cost base, quality, operation, performance, all those things in the problem side. The synthesis side, you know about the process. The analyze side also, the design subject to analyze what you need. In the evaluation process, measuring the design against specification of the problem. Final presentation, the documentation of the design through drawing, material specification, assembly line. Next method is Paul and Pitch method. In this method, you know about the task, content of design, the concept of design, embedded design, detailed designs. In this all aspects, you know about dimensional tolerance, metal, and forming for individual component, how it's working. The task, what is the market, the company economy, then plan for an task. After what is the requirement, again you go for an the design of detail the product detailing, and then layout. This is detailing, embodiment design, conceptual design, planning and clarification task. In this, you know about optimization method for an production, uh, and then for an principles. Shock method. This is one of the method for identify for the viewpoints to establish the fitness of the uh, proposed design. The proposed design means the process is repeat until the design is at the end. You will go for a drawing part. What is the requirement? You built in a model. This is model one. There is a sum of modification. Again, it's go for analysis and evaluation. So you create the model two. There is a sum of modification. Again, you go for an analyze to modify those things. It is go for an n number of models. So this is first layout is conceptual model. This is preliminary model. N number of time you will create for an planning and manufacturing and testing. In that testing, you go for a plan, manufacturing test, finally get in a product. Elect method, this problem identification, preliminary ideas, design, reformation, analyze this uh, decision implementation. First, Ehrlich method is a problem identified and then idea. The idea to refinement. That refinement interrelate with the process, analyze. It's get a decision to implement those things. This is identify the problem. If you identify those things, what is the background, what is the economy, what is the data, what is the case, what is the need, what is the effect, the type of problem. In the type of problem there is two category, design needs, design shortcomings, bad condition, need for solution, market potential. In the another one is design category, features, number, size, weight, price, all those things. In this step it's fine for any problem identification. Write a statement, list a requirement, list that limits, sketch what is the effect. You will list out the requirement for a sketch. This is a preliminary. There is a brainstorming session. Prepare the sketch and then discuss. Research existing design. Conduct a survey. This is the generic idea. Already we know about what is the new approach, list of idea, sketches, idea, brainstorming notes, all those things to get in a final solution. Design reformation means it is a cyclic process. What's the benefit? Increasing the productivity, high quality of design, reusable and easily change the design, easily to read, simplified, sharing, and then documentation, skill of the designers, then physical objects in a virtual workshop. Hardware, what is the hardware? The system have the hardware, software. The hardware means input device, output device. Input device, mouse, keyboard, digital displaced, and then output is monitor, plotter, printer. The input device is keyboard, mouse, joystick. Then input device, another is scanning, barcode scanner, camera it's a input. The output is what is a monitor or LCD to display those things. It is a monitoring its output. Another one is printer plotter. This is a displaying device. CRD monitor, flat monitor is a CRD type. It's electron gum slightly coated with a surface. It's like CRD monitor. Cathodes focusing system, and then glass tube anode, and then anode it's also coated for a layer for the. This is LCD, liquid crystal display. In that liquid crystal display, there is a mirror. Another one is for an filter, negative electrode, and then a LCD layer. In that LCD layer, there is a glass filter. Another finalized for the this displayed the image. This is LCD TV available. LED light emit diode. It's a diode. It is a two-lead semiconductor laser source, P and N junctions. When that P and N junction activate for the light emitting diodes, there is a pixel and then a square in the shape. This is a geometrical modeling for geometrical purpose, front to top, right side view, how to evaluate for end cross section, all those things. Another one main area, geometrical model. The computer can help for a software is a geometrical model. In the geometrical model, there is a wireframe, surface solid modeling. Wireframe modeling means it's directly CAD, it's a 2D element. In that element, there is an object. It's a traditional design to orthogonal view like plan, elevation, and end view are used to object for the view A, B, C, D, the view of wireframe for a rectangle, those things. This is difference between 2D and 3D. In 2D, there is a two axis, 3D axis, three axis coordinate points. Curve edge, reference edge, circle, ellipse, and then additional view of the sections. It's a curved surface representing the suitable generation. 3D, 2D, it's used for coordinating points to for one element is 2D. Many recurrent surveil users coordinate the system. It's used for an 3D. Surface modeling. Already you know about zero thickness CATIA modeling. It's a surface model. What you have in a surface in the XY plane, you create in a surface. It's a standard box, pyramid, edge, shear, cone. All those things are surface modeling. This is NU or BS, non-uniform rational B spline. This is the model. Solid modeling. The solid modeling, there is a bounded or bounded thing. Another one is homogeneous three-dimensional and then fine. This common scenario, there is 3D modeling, CSG, and then C rip, and then boundary rip, B rip, and CSG. It's common one for the modeling. There is Boolean operator like union, differentiation, intersections. In this section, this is normal, then A union B, and then A differentiate B, A intersect B. This is salient feature of rip. How you go for an rip? You will design for an a plane and given a rip option to construct for 360. Thank you to all.